Now, in this video, we are going to take up a problem on projections of laminas. The problem reads as a 30 degree to 60 degree set square of 60 mm longest side is so capped such that the longest side is in HP, making an angle of 30 degree with VP. The set square itself is inclined at 45 degrees to HP. Draw the projections of the set square. So here, how to analyze this problem and solve it by manually. See, he says it is a 30 degree 60 degree set square of 60 mm longest side. It's so capped such that the longest side is in HP and making an angle of 30 degree with VP. The set square itself is inclined at 45 degrees to HP. So first we should always look at the surface inclination. Which is the surface inclination here? The set square itself is inclined at 45 degrees to HP. So this is the surface inclination what we are talking about. So if you say that a surface is inclined at 45 degrees to HP, so obviously that surface should be initially 0 degrees to HP. If it is 0 degrees to HP means what? It will be parallel to HP. If it is parallel to HP, where you can see the parallelity, I can see it in the front view. But where it will going to be the image? The true length will be on HP. Since the true length is on HP, so obviously we have to start the problem from the top view. So this is the initial condition. Then he says longest side is kept on HP. So which is the longest side? The side which is 60 mm is the longest side. So this side should be perpendicular to VP and parallel to HP. Why? Because if it is perpendicular to HP and parallel to, it is perpendicular to VP and parallel to HP, then you can see a point in the front view. So you should get the longest side at the extreme left corner or to the right corner. Let us see how it will going to work out, how it will going to be seen in 3 dimensions. So here, the first thing is, so this is the vertical plane and this is the horizontal plane. So here, this is the longest side what we are talking about. This longest side is perpendicular to VP. So because it is 90 degrees to VP and also parallel to HP. How do I know that it's parallel to HP? Both B dash and C dash is on horizontal plane at the same point. So since it is parallel to HP, so we are getting the true length. What is the true length? True length is the longest side distance what he has given in the problem. So that will going to be the true length of the line. So he says it is 30 degree to 60 degree. So obviously we have to start the problem from the top view. So here, since it is a 30 degree to 60 degree set square, you can see there are 3 sides. And when you look from the front view, all the sides are resting on HP. A dash is on HP, B dash is also on HP, and C dash is also on HP. So how to read this problem? How to read this size? It is A dash, B dash, B dash, C dash, and C dash, A dash. So these are the 3 sides in the front view. So when you look from the front view, the image will go to fall on the vertical plane. Since the entire surface is perpendicular to VP, and so since it is perpendicular to VP, when you look from the front view, you get a line in the vertical plane. And here, this side is a corner and this side is a longest side. How do I know that it is a corner here? When you look from the top view, you can see this is the point what we are talking about, A, which is the corner, and B dash, C dash is the side which is seen here in the top view. So when you look from the front view, all the sides are parallel to HP. Therefore, you are getting the true shape in HP. So we have kept the longest side on HP. Since it is parallel to HP, so we can see the true shape in the horizontal plane. So here, this is how you will be able to analyze it in 3 dimensions. Now how to start with the problem? So here, draw the XY line and you mark VP and HP. So I need to construct this 30 degree, 60 degree set square. So the longest side has to be perpendicular to VP and parallel to HP, so that you will go to get in the front view a point, so that through that point you can be able to rotate it. So for that reason, so first initially after marking XY and VP and HP, so since HP is below XY line, draw a perpendicular line to the XY line. Then consider any point, you mark that point as B. By using the compass with by taking 60 mm with B as center, cut an arc on this vertical line. So you that mark this point as C. Then using the protractor with B as the center and with respect to this vertical line BC, you measure an angle of 30 degree with respect to BC. Then you mark the point. Through point B, you draw a line, and similarly with the C as center with respect to this vertical line C to B, you measure 60 degrees by using the protractor in a clockwise direction, and you mark this point and join C and draw a line through C through that 60 degree line which is marked with respect to this vertical line, and these two lines will going to intersect at this point. You mark that point as small a. So this is how, and join between A to B, B to C and C to A with the dot line. Once you do that, now I need to write the front view. How to write the front view? From A you draw a vertical projector to the XY line. Similarly from B and C you draw a vertical projector to the XY line. So then I need to name them. So when you look from the front view, A is near to the observer, so it is visible. B is near to the observer, it is visible. But C is away from the observer and it is coinciding with the point B. Therefore, C dash will going to become invisible. So you mark these points as A dash here, then B dash without bracket, then C dash with bracket. So this is how you will be able to write the front view for this particular top view. So here A dash B dash is parallel to HP, so you are getting the true length in HP, and B dash is also B dash C dash is parallel to HP. So therefore, in the top view you will going to get the true length. Similarly, C dash and A dash is parallel to HP. Therefore, you are getting the true length in the top view. So since all the lengths are of true length, therefore it is in true shape. And this is the surface which is parallel to HP. The entire surface is parallel to HP. Therefore, you are getting the true shape in HP, and it is perpendicular to VP. That means it is 90 degrees to the vertical plane. As you see here, 90 degrees to the vertical plane. Therefore, you are getting a line in the vertical plane on the front view. So this is how you will be able to write the top view and front view for the initial position of a 30 degree, 60 degree set square. Sir, can I take 60 degree here and can I take 30 degree? Yes, you can take it. You can take this 60 and this 30 also. Then it will going to come here, this side, and you will going to get somewhere the point here. So this is how you will be able to write the initial position. Now, the next thing is, he says, the surface is inclined, the set square itself is inclined at 45 degrees. So, such that it is the longest side is on horizontal plane. In this figure, if you see, all the sides are resting on HP. But what he wants is only the longest side has to be rest on HP. So, which is the longest side? This BC is the longest side, which is on horizontal plane. So, take any convenient distance. So, and you mark that point. So, you mark that as B dash C dash. Then, you rotate this entire surface by an angle of 45 degrees. This is what we have shown here in the second position. So what we are doing it is as good as we are rotating this line, this entire surface by rotating at an angle of 45 degrees. That's what we have shown here. If you want to rotate this entire surface with respect to HP as 45 degree, what happens to this line? In the image, when you look from the front view, the image is also getting rotated in the front view. So once you rotate at 45 degrees, therefore, which line we are rotating? I am rotating this line here. Therefore, with this as center, taking the radius of this, then with this as center, cut an arc on this, and you mark that point as A dash, and you mark this point as B dash and C dash in bracket. Now, to this I need to write the top view. How to write the top view? Actually, what we are rotating this means what? We are rotating this entire surface by an angle of 45 degrees. That's what we have shown here. A to B, B to C, and C to A here. So once you do that, now I write the top view. So we know that B dash C dash is on XY line, that is on HP. So you draw a vertical projector from here, and similarly you draw a horizontal projector from B, and also we are draw a horizontal projector from C. Both these two lines will going to intersect at this point and this point. You mark that point as B and you mark this point as C. Then draw a vertical projector from here and draw a horizontal projector from here. That is this line and this line. You mark this point as A. So this is the top view for the second position when the surface is rotated by an angle of 45 degree. What is the position of the surface with respect to VP and HP in this second position? That a surface is inclined to HP, but still it is perpendicular to VP. Therefore, you are getting a line in the front view. Now, whether this second position top view will be in true shape? No, because A dash B dash is inclined to HP. Therefore, AB will be in apparent length. B dash C dash is parallel to HP. Therefore, BC will be in true length. That is the reason why what the line you have BC here, that 60, the same 60 will be here. What happens to this line now? As A dash B dash is inclined to HP, so here this is the point, and here this is the line what we are talking about. This will be in apparent length. What does the apparent length means here? The length of this AB will not be equal to the length of this here. That means the length of AB here is more, whereas the length of AB is here less. And similarly, C dash and A dash is inclined to HP. Therefore, CA will also be in apparent length. So that means the length of this will be definitely more than the length of this. Since the two sides are not of the same length as what we have here, therefore, in the second position, you will going to get the apparent shape. Now, how to proceed with the orthographic view. So you take any convenient distance from between this point to this in the first position. So you mark that point as B dash and C dash in bracket. Then with this as center, by using the protractor with reference to the XY line, you measure an angle of 45 degree in clockwise direction and mark that point. Then through this point, on that 45 degree point, you draw and extend it. Then by using the compass with B dash C dash as center, taking the radius of B dash A dash with B dash C dash as center, cut an arc on this. So you will going to mark this point as A dash. Then join B dash C dash with A dash with a dot line. So now the surface is inclined at 45 degrees to HP. Once the surface is inclined at 45 degrees to HP, now I need to write the top view. How to write the top view? Draw a vertical projector from B dash and C dash to the top view, and draw a horizontal projector from B of the first position to this line. Similarly from C also draw this to this line. Both these two lines will going to intersect at this point and this point. You mark that point as B and you mark this point as C. Then draw a vertical projector from A dash and draw a horizontal projector from A. Both these two lines will going to intersect at this point and you mark this point as E. As we have joined between A dash B dash with a dot line, so you join between A to B with a dot line and B dash C dash with a dot line and C to A with a dot line. So this is the second position top view, wherein this shape is not in true shape because A dash B dash and A dash C dash both are inclined to HP. Therefore, AB and AC will be in apparent length. B dash C dash is parallel to HP. Therefore, you are getting the true length in HP. So what is the true length here? Whatever the side you have in the initial position, the same thing will going to be there here also. But whatever you have this distance here will not be equal to this distance here. So this distance will be less and this distance will be more. So that is the reason why AB will be in apparent length. Similarly, AC also, as C dash A dash is inclined to HP. Therefore, AC whatever you have here, this will be in apparent length. So this length will always be less than this length AC, which is true length. Why? Because C dash A dash is parallel to HP or parallel to XY line in the front view. Therefore, you will be getting the true length in the HP or the top view. So everywhere you will be having the concept of the projections of lines. So, but to understand the projections of laminas, first you should understand what is the projections of lines, that is the concept of true length and apparent length. If you understood that, then this projections of lamina will going to become easier. Then the edge on which it rests, this edge on which it rests is inclined at 30 degrees to VP. So what is the inclination given? The inclination given is the true inclination. But whether that BC is in true length or not, we need to check. Why? Because, so since the inclination given for the third position, top view, that is longest side is 30 degrees to VP, is the true inclination. So in the second position, is BC is in true length or not, we need to check. So that means B dash C dash is parallel to HP. Therefore, here you are getting the true length. What is the true length of BC? The true length of BC will be equal to 60 mm. So here also in the second position also BC will be equal to 60. Therefore, this slide is in true length. But whereas AB and AC will not be equal to this and this, therefore this will be in apparent length. But he has not given anything reference to this. Instead, he has given the reference to that. This edge on which it rests is inclined at 30 degrees to VP. So you need, as we know, that from the projections of lines on true inclination line, you have to get the true length. So here you rotate the second position top view by an angle of 30 degrees to VP. How to do that? So at this position, what is the position of the BC with respect to both HP and VP? With respect to both HP and VP, the BC is parallel to HP and perpendicular to VP. Since it is perpendicular to VP, you are getting a point in the vertical plane. And now, since it is parallel to HP, you are getting the true length here. So we rewrite the second position. Therefore, what you can do is you rewrite the second position top view by rotating at an angle of 30 degrees with respect to VP directly. So we are rewriting the same sketch here. So that means once you rotate the second position top view, that is what we have A, B, C, which is perpendicular to VP, you are rotating by an angle of 30 degrees to VP. So this is the position of the 30 degrees 60 degrees set square when it is in space. One should do that. Now to this, so when you project this, when you look from the top view, you project this point directly here and join. You mark it as A. So join B to C, C to A and A to B with a dark line. So this is the top view position, that is the blue color one, which is of the horizontal plane. Then when you look from the front view, this point will going to be on XY line, B is also on XY line, whereas A, you draw a vertical projector from A to the VP and draw a horizontal projector from A dash. Both these 2 points will going to intersect at this point. You mark this point as A dash. Then as we know that A to B is joined between A dash, B dash, then B to C, that is B dash, C dash, and then C to A, C dash, A dash. So this is how you will be able to write you will be able to visualize the concept of the 30 degree, 60 degree set square. So this is actually the final position what we are talking about. How I can be able to do it? By using the orthographic view. So what I need to do now? So as we know, this is the in the second position top view, as the B dash C dash is the longest side, which is still on the horizontal plane, which is parallel to HP. Therefore, you are getting the true length here. Once you know that this is the true length and the inclination given is also true inclination, what you do? Consider any point and draw a horizontal line at any distance from the XY line. So from this, with reference to this horizontal plane, you measure an angle of 30 degree by using the protractor with reference to the horizontal in a clockwise direction and then draw an inclined line. So this is the true inclination what he has shown. Then since on the true inclination line I have to transfer true length. So since B dash C dash is parallel to HP, therefore you are getting the true length here. So then by using the compass, you measure the distance from C to B with C as center cut an arc on this 30-degree line. So you got the point B. Then with B as center, take the radius of B to A. With B as center, from the third position, with B as center, draw an arc. Similarly, you measure the distance from C to A of the second position top view. In the third position, with C as center, cut on the previously drawn arc. So you mark this point as A, then join A to B, B to C, and C to A with a dark line. Then I need to write the front view. Draw a horizontal line, extend that XY line, and draw a vertical projector from C. Since C dash is on XY line, you project this C to the XY line. Similarly, from B also you project to the XY line because both B dash and C dash is on XY line. And then you draw a vertical projector from A to the front view and draw a horizontal projector from A dash. Both these two lines will going to intersect at this point. You mark this point as A dash. As we are joined between A to B, B to C, and C to A with a dark line, you join between A dash to B dash, B dash to C dash, and C dash to A dash with a dark line. So this is how you will be able to complete the drawing by manually, and also you can be able to analyze it visually. Finally, how do I know that my problem is right? Even in the final position, you can see that the longest side is resting on HP. The longest side which is resting on HP is inclined at 30 degrees to VP, and the entire surface is inclined at 45 degrees to HP, and this is the true shape of 30 degrees, 60 degrees square, with the longest side is 60 mm. So this is how you will be able to visualize it in 3D, and also how I will be able to write on orthographic view or by using the sketchbook. So understand the reading the drawing is very important. Then in each of these, how this each line, whether it is in true length or the apparent length, you should be able to make out the differences, and that will going to help you in solving this particular problem. Thank you.